Extreme teardown time again. Here we've got this Lumix digital camera, sort of fairly cheap plasticky digital camera, but it's got an image stabilizer, so there might be some interesting optics going on. It doesn't really work. You turn it on, it says please turn it off and on again. I think the lens is jammed, can't get any movement out of that, so it's going to be extremely torn down. As we're not too concerned about putting it back together, this is just a case of literally undo every single screw in sight and hopefully it will sort of fall apart. Right, the front comes off. We've just got the two flex connectors for the LCD, one for the main LCD and one for the backlight. Just the LCD in the back and some plastic webby button connectors. One thing to notice on here, there's actually a bit of metal shielding around the buttons. Now I'm guessing that's probably not so much for EMC as for static. If you look, there's a few little spring clips on the PCB. There's one there and one there to make contact with this. Because if you've got this plastic camera, you pull it out of out your pocket, you've potentially got quite a lot of scope building up a static charge. So if the distance between the finger through the gap to these switches could easily make a static spark, so you want to have it discharge the shielding rather than to your board, because at the very least it could cause it to crash. In the worst case it could actually cause some damage. Let's see what's up. Right, that's the front off. Again, you can see some shielding. There's a bit of foil connected. About the only bit. This is all metallized plastic, but there's a metal ring around here. And again, you see this shielding foil here that screws and connects onto the contact on the main assembly. Just to again, mixture of static and RF interference. Well, you can see the whole thing's built around a sort of central plastic chassis, battery holders here. Here we've got the high voltage capacitor for the flash. Now, one thing to be aware of, whilst I would fully encourage people to take electronics apart, if that capacitor's charged, it's probably not particularly dangerous, but it will really hurt if you stick your finger across it, to the extent that you may well drop it if you're actually trying to repair a camera rather than taking it apart and that flash cap's charged. If you touch it, you will certainly know about it. The rating on this one is 80 microfarads at 300 volts. I'll give that a charge in a minute just to show you what the discharge looks like on there, but you can actually see it says high voltage on there. But any camera that's got a xenon flash as opposed to a bunch of LEDs will have one of those capacitors in there. It's big enough you usually see it, but just be aware that if you stick your finger across it, it will hurt. So it looks like we've got a complete sort of lens assembly, which actually looks like it's a separate plastic assembly here. Let's take the board off, because that should come off fairly easily. Another flex connector. Generally these flex connectors, there's usually two types. In the small stuff they tend to use a sort of hinge latch. It's either a front loading one like this, where the latch is on the same side as the flex goes in, or it's a back latch. I think this one here is a back latching one. Let's see, that was a little bit charging that cap, as I just found out. Let's see what it is and discharge it. Yeah, you can actually see there's a... Just try... Yeah, there we go. That's the rest of that charge. I mean, this camera probably hasn't been switched on for quite a long time, so that charge can stay there for a fair old time. Right, well, that saved me charging it again. Let's just have this board out. The other thing to bear in mind is sometimes, because the cameras are designed to be ready to go fairly quickly, they'll quite often charge the cap as soon as you put the batteries in. They'll keep the cap charged, just so the flash is ready to go fairly quickly. So even if the flash is disabled or turned off, you may find that it still keeps the capacitor charged anyway. So don't assume that it isn't charged just because the thing's been switched off or the flash is disabled. Right, I've got the top panel here. This is a little bit unusual. There's actually, instead of a flex, there's actually a connector that plugs this board straight down onto the connector here. doubt there's really anything to see on this board, but we'll take it off anyway. You never know when you might see something interesting. Right, so what we've got on here is the little rotary, it's probably a rotary encoder or something similar for the rotary control. You've got the push button, that's probably a 2-level push button, and just the switches. There's a little switch there which is probably for this, the wide telephoto thing. So yeah, and a little spring, so nothing exciting there. Can't be bothered to unthread this strap, so chop that off. Right, let's have this board off. Again, here's a back latching flex connector, so it flips up on the back. And then just get the flex out. That's a brilliant. Alright, it looks like these battery contacts are soldered through the PCB, and that's what's holding it in, so let's just take those out. Those leads are just, this is a little piezo sounder for making beeps. I'm not sure there's actually a split. I don't know if this has got any audio. I don't. Let's have a look. I can't see a microphone. So there's a little control thing. Not sure if this even does audio. Well, it's got a movie thing, but I can't see any signs of any audio yet. Right, so this is the main PCB. So let's have a look at what we've got on here. More detail. Once you've got the connectors, power in, and AV. This is going to be power supply circuitry. You can tell by all the big capacitors around here. There's an inductor there. That will be a. These, I'm guessing, are accelerometers or gyros for the optical image stabilizer, because you can see there's 2 packages mounted at right angles to each other, and they're fairly big, chunky packages. Obviously, that's the SD card slot. Here we've got the flash capacitor. This is the actual assembly of the flash tube. Notice you've got some fairly thick cable wiring here just because of the high voltage. It looks like this is the trigger coil. This produces a high voltage spike to actually fire the tube, so basically the tube is connected across the capacitor. Depending on the model, it looks like, yeah, there's a device in series with the capacitor so that it can actually switch off an old-fashioned traditional flash just discharges the whole capacitor into the tube. More modern ones have the ability to disconnect it, so it can do things like the anti-red eye, where it would discharge a little bit, then switch off, then switch on again, so it can do multiple flashes. And back here, this will be the transformer to step up the sort of 200-300 volts for the flash capacitor here. So this all is going to be the inverter. I'm guessing a lot this gap here, that sort of slots in here, I'm guessing that's to provide extra insulation from the high voltage to the low voltage side. What we've got here, that's going to be either a battery or a capacitor for the backup for the real-time clock. That'll be a 32K crystal, 32 kilohertz crystal for the real-time clock. Just various chippery. That's probably going to be the main processor, and you've got probably a flash and a flash for firmware and an SRAM. Don't immediately recognise those numbers, but that's where all the brains are really. There's a little crystal there for frequency reference. Nothing particularly exciting or surprising to know the crystal on that side. That's sort of pretty much it. It's just more electronics. Just cracked the top off of one of these sensors. I was actually quite surprised at how complicated and intricate they are internally. They seem to have a sort of long beam which is mounted so it can move slightly from side to side. So I'm not totally sure if these are accelerometers or gyros. I would have thought accelerometers, considering that it's looking for sort of lateral shift, but maybe they're also measuring tilt and rotation. I don't really know, but they're quite surprisingly complicated. Right, just going to whip these chips off. These are going to be BGA, ball grid array chips. Just curious as to how ridiculously fine the pitch is and what sort of number of pins they've got on them. So just give them a quick blast of some hot air. So you can see this main processor's got a pretty ridiculous number of pins on it. Right, this is where I think it could get a bit more interesting, the optical assembly. So let's get this out. Right, this is a separate module, probably so they can sort of manufacture and test this separately rather than building it into the chassis, but also because it's an optical assembly it's quite important that it's mechanically stable, so having it as a separate module means that when the camera gets squeezed and twisted it doesn't mess up the alignment of the optics. You can see a couple of little motors here, there's a little one there, a large one here. I'm guessing the largest one is going to be for the in and out movement. And there's obviously these flexes, shaped flexes to connect all the various little bits. Inside there's going to be sensors, motors, all sorts of other odds and ends. This big section here, this is going to have the actual image sensor, which will either be a CCD or a CMOS sensor. For some reason I've used very small Torx screws on that one. Now, these are actually T3 Torxes, which are about the smallest size you're likely to see. Fortunately we have the equipment to deal with these. These little springs there. Not sure if those springs are mechanical or for shielding. So this is the image sensor, it's probably a CCD. A few little bits of circuitry, but most of it's going to be on the main board. You see a slight sort of greeny blue tint on there, that's the infrared. There's going to be various optical filters. One is going to be an infrared cut filter because the infrared content in the image will tend, because the sensor itself is going to be quite sensitive to infrared, so you need to cut the infrared, otherwise your image will appear red if it's got a large amount of infrared content that's not visible to the eye. So depending on the type of light source it will skew the colour, and this actually comes off. Yeah, so that's the infrared filter. And then obviously the chip itself will have RGB filters actually on the die. Right, I think I'm going to try sticking some volts in this motor and see what happens. Oh, made a noise. Oh, didn't sound good. Yeah, it looks like it's struggling. There we go. Yeah. Till that. There's a little motor unit here. This looks like there's a little motor and gear assembly. Not too bothered about preserving this flex, so we'll just chop it. Just put some power in this. Yeah, you can see there's a little gear on the end of that. So that's just a complete little motor and gear unit. Got here, right, okay. Oh, now I think we can see the reason it was jammed. There's what looks like, yes, that's sand. So somebody's taken a little trip on the beach with this camera, and camera mechanisms really don't like sand in them. That is pretty much unrepairable when it gets like that, so we don't need to feel guilty about taking this thing to pieces. I'm guessing that front assembly is for the optical image stabilizer. Yeah, you can see the lens actually actually floats around a little bit, and there's these actuators. We'll get in there and have a look at those. Get all the sand out of there. Now what's this bit do? So there is one lens on this section. There's what looks like some sensors. Oh right, yeah, I think there's a tiny little, what I'm guessing this is a stepper motor, and not sure how easy that is to see, but there's a little screw thread on it so that this It looks like this whole assembly moves up and down in this direction. Because that's a stepper, I can't easily run it. I'm just guessing it's a stepper just by the way the terminals and coils are arranged. It looks a bit too small to be a DC motor. Yeah, so it's just a tiny little lead screw type thing there. So that's going to be doing the focusing by moving this backwards and forwards. Right, we've got two separate flexes going into this bit here. We've certainly got the image stabilizer. I'm guessing there's going to be a shutter and or some aperture control in here. Let's see if we can figure out how it comes apart. Okay, we need to get a bit more violent with this, I think, because the sand's just going everything up. So let's just chop this outer ring off. Alright, okay, looks like we've got two bits of plastic that rotate against each other to give some adjustment here. So this is just really gummed up with the sand. Yeah, so you can see this it goes in and out. There's sort of interesting, it goes sort of in and out, so it's doing some funky optical stuff. Yeah, in fact you can actually see there's the inner part moves differently from the outer part, so you've got the outer bit moves in and out, and so does the inner part, so it's quite a clever bit of engineering. So that's just the outer with a lens in front, and this is the clever bit. Okay, so we've got a shutter in here as well as the optical image stabilizer. They look like they're probably two separate pieces on the side. So let's see if we can make this shutter do something interesting. Let's turn the voltage down quite low because they can be a bit fragile. I'm guessing there's two sets of contacts here, so it may be two electromagnets. That's what was used in another camera I took apart a long time ago. Oh, there we go. Oh, there we go. So it's open and close. Okay, so this looks like the shutter control. One polarity closes it and the other one opens it. You see opening and closing there. But here, this one seems to be the aperture. Flick it that way and then open the shutter. You see it's actually opening a bit further. It looks like it'll only do that when it's shut. I mean, this is a very clever, extremely fine detailing now, and these shutter things are microscopically thin. Looks like there's some sort of filter as well over the top of that, and this is just wafer, really thin. I think we should connect a signal generator to this, just see how fast this thing will move. Right, we connect up to the signal generator. This is producing a bipolar waveform, so it's alternating the polarity, and you can see the shutters opening and closing quite nicely. Let's crank the speed up a bit. That's 10 hertz, 10 frames a second. $20, 26, 30. So that's opening and closing 30 times a second. It's quite interesting, quite nice. At some point you'll probably see some strobing effects with the video, up to 50 hertz. It's stuttering a bit there. That's 70. Yeah, it's getting a bit dodgy at about 70 hertz. So that's pretty impressive for a simple mechanical shutter in a cheap consumer camera. I wonder if you could use this to make some 3D glasses. It looks like these other ones are other connections are controlling the aperture. Again, that's closed it down, but it's also stuck this. Looks like a filter across it. If I open it up again, it widens it, but also takes the filter away. I've tried putting some signals onto the image stabilizer stuff and I can't really get anything happening, so I think it's going to be taking apart time. Let's just pull some screws out and see what we can see. Right, you can see this shutter assembly is a completely independent unit, which I'm sure somebody must be able to think up an interesting use for a nice, small, very fast shutter. It's very... Right, and here we can see what I'm guessing is two actuators here. It's sort of, yeah, it's like a completely floating assembly here, sort of free to move in X and Y directions. You actually see there's like some little rails there, and there's another one under there that you just about see. So this shifts the lens in response to the motion detected by the accelerometers in the main camera body to compensate for shaky hands. So there's actually quite a large number of conductors in that flex. They're so small it's very hard to see. It's got to be at least 10 or so. Tiny, tiny, tiny traces. There's this sort of long free piece here, obviously, because that's flexing as the whole thing's moving, so you don't want that to fracture. So it's not got a nice long curve on it. Let's see if we can get this apart a bit more. Figure out how it works. Right, so we've got what looks like a couple of magnets in here, nice powerful neodymium magnets in there. Now there's what looks like a chip there, which I'm guessing is position sensing. I wonder if actually they've wound coils on the PCB to provide the actuation. I can't actually see anything in here that's making it move. I think it must be something like that. Let's get it further apart. Right, now there's pads here. I'm guessing those pads are for connection to a coil. I can't see the coil. Interesting. So basically it's this PCB and the magnet that's actually doing the motion. So what I think we probably have here is a coil that's actually wound on PCB traces or sandwiched in between. Right, now to magnify this a little bit more, I've stripped the flex off the front PCB. So what we've got here, there's a couple of little chips which I'm guessing will be Hall effect sensors, so it can actually sense its position. And this is the front PCB, and this, it's quite hard to see, has actually got extremely fine, those are the pads where it connects to the flex, but they've got some really super fine coils actually as part of the PCB. I think I'm going to have to do some macro stills to actually be able to see this. Put some light through it. Here's a still showing that coil. That's about 5mm across on the smaller dimension. Let's just see what's inside this shutter assembly. There's a couple of electromagnets in there. Another screw. These screws are getting ridiculously small as you get down to this level. Right, you've got these insanely thin bits of plastic material, quite hard to pick up. They stick to the bench. Yeah, 0.05 of a millimetre. Right, so it looks like there's some little levers here that are actuated by the magnet, by the electromagnets. Yeah, so there's some little pivots and some little, yeah, so as that magnet moves, you can see it moves the aperture bit. Right, yeah, well, the way this works is there's a magnetic sort of circuit that goes from there through the coil to here, and then in the middle of it there's a magnet which is going to be magnetised sort of crossways, so that it's almost like a little motor. You've got the effectively two sides, sort of one there and one there, so as the magnetic field across those changes, this little thing rotates by about 1/8 of a turn. If I take that bit of metal out of the way, you can probably see it a bit better. So it sort of just rotates like that, which is rather clever and very, very small. Alright, one last thing we've got left here is the LCD. Let's take this out and have a look at this. So this looks like a fairly standard sort of tin enclosure for a little TFT panel with a LED backlight. Right, so this is just this is the actual LCD panel here. We've got the driver chip along the bottom, and we've got the two polarizers. So these are polarized, so if you rotate it, it goes black and white because the LCD twists the polarization of the light going through it. There's another one on the back. And we've got the backlight. One thing you'll find if you take apart pretty much any LCD, and I do recommend that you try it, is that you've got all these interesting, it's not just a bunch of LEDs, there's quite a lot of optical materials in there. So obviously there's a rear reflector that reflects it, all the light going back forwards again. You've generally got a lump of plastic that conducts the light across, and this has usually got all sorts of interesting patterning on it, which is designed to make the illumination even across the whole surface. And then you've got all sorts of weird and wonderful funky optical materials like this. Obviously on the big LCDs you get some really massive sheets on of this stuff, which is basically what there's two different types of sheets here. These are just simple diffusers, so this is spreading the light out so it's even. What these are doing are these are actually making the light more directional. So instead of the light going in all directions, it's actually concentrating the light forwards to maximise the amount of light that comes forward from the LEDs. Right, so I just powered this backlight up. Let's just stick it back together so you can see the effect of these sheets. So we'll just overlap them like that. You can see that the light gets progressively brighter. Each of these two inner sheets, one works side to side and one works up and down. So as I change the angle of view, you can see that's gone fairly dark because it's actually concentrating the light forwards. As I take it direct on, you see a lot of light, and then as it goes it falls off fairly sharply after that. And again, if I tilt it this direction, you can see how compared to what's coming out the backlight with just the diffuser, by the time it gets through all these funky materials, it's actually making quite a difference to the amount of light that's coming through. They look quite interesting to look through as well. So there you have it, that's all the stuff that's in a camera.